Hi, greeting to everyone. Today I am going to discuss structural engineering and design. In most of my subscribers, they wanted me to continue some advanced sessions rather than talking about the primary sessions. So I will continue the primary part, but so because of my subscribers wanted me, I'm going to start in this lecture series structural analysis and design. Here I will start with very fundamentals, then I'll move into the advanced area in future. So let me start with the basic introductions of structures. So let me start first the definition of structure. So what we define as a structure refers to a system of connected parts to support a load. You know, here we have to understand the characteristic of structure. So if you take the structure basically have three characteristics. One is it has certain strength, and it has certain shape, that means stable. It is a stable shape. Then it has, we have to invest some money, we have to spend some money to make this structure for the manufacturing, it seems. So if any objects, if it is satisfied these three things, strength, shape and cost, so we can call that object as a structure. For example, so let me take bottle. Bottle is the structure. The answer is yes, it is a structure. It has certain strength. When you are applying the loads, so it will stable until getting some amount of load. After that only it will brittle. So bottle has some strength. Then it has certain shape. It has a fixed shape, stable. Then it has some cost to make that product. We have to invest some money. So therefore bottle is the structure. So you can see, so whatever I have uploaded here, the three photos, this is interesting structures. So what you call this structure as engineering structures. Here whatever the definitions I have given here, it is common for all the structures, but in this structural analysis we are going to discuss only the engineering structure. So what we define as an engineering structure, any structure so that contribute to the infrastructures of particular unit. you know everyone's you I hope everyone's what is the meaning of infrastructure. So whatever I have uploaded here, these are the engineering structures. So we can see the structures: buildings, bridge, towers, roads, even highways. Those are the engineering structures. Okay, how to make the structures? Everyone as a civil engineers, you should aware the civil engineering project cycle. So that means any structures, before building up, they have to plan well, they have to create some concept, they should make sure the following things before going to the building stage. you know the very first ones, very important, your structure is safety of the structure. So before constructing the particular structures, before going to the construction phase, so as an engineer, structural engineers, the most important role is they have to make sure the safety. Here there are many things we are doing. So for example, if you analyze, that means if you study the material separately, You know, if you take a buildings, it's combination of many materials. So when you study the materials, it's separate independently, that means individually. So that is what we are doing normally. When you study the material individually, so you can get the basic idea about the materials. You will feel sometimes it's safe. But when it's come to the combined effect, the integrated design that we are called as integrated design, in that case, as a structural engineers, is very difficult part to make sure the safety of the structures. But it is very important for the considering the combined effect as well. This is the very first one. Second one is the aesthetics. You know, all the structures, whatever structures we have talked about daily, the engineering structures, the one of the aim is making aesthetically the view of the structures. So aesthetics, whatever the design, the architecture provide the basic concept, the what is that, the architectural concept of the structure. As structural engineers, so we have to make sure we can't compromise the aesthetic of the building, the view of the building in the certain degree. After the certain degree, beyond the certain degree, we can't compromise. As a structural engineers, we have to come up with a alternative plan to make it the architectural concept succeed in the final stage. It's very important. So the third one is the serviceability. What we define as a serviceability, the usable of buildings. You know, all the buildings or all the structures, it's designed or constructed targeting on a certain functional requirement of the structure. For example, if we take the hospitals, it has certain functional requirements. So we have to accommodate, if it is a hospitals, there should be ward. We have to accommodate more persons, within the certain floor area. So therefore, whatever the structures you are proposing, it should be serviceable. It should be usable to the particular purpose that intended purpose should be satisfied. It is very important. The fourth one, economic, you know, so everything based on the money. So we have to look after money. So no need for the explanation. The final one, the environmental constraints. Environmental constraint in the sense, it should be everything surrounded by your, that means surrounding in your structures. So for example, let's say a soil, the ground condition of your land when you are constructing the building, the ground condition of your land. If the ground condition is poor, so you can't go more than a certain story of the buildings. You know, as a client, if you have an idea of constructing the 8-story buildings, if your land grounding is not supporting that, you have to limit with the less number of building, let's say five story. That means you have a plan to 10-story, but your ground is not allowed to do more than 5-story. So like that is one of the environmental constraint. So another thing is environmental constraint. Sometimes it will come from the regulations. You know, regulations in the sense, there may be each country they follow some different regulations. It's called building regulations. Based on the building regulation, in certain area there might be some restrictions regarding the number of stories, regarding the, what is that, regarding the that means rear space, front space, side space of the buildings. So everything will come under this environmental constraint. So therefore, as a structural engineers, if you want to do the perfect design, a structural engineer should have fundamental knowledge of material properties and law of mechanics. So material properties should be in your fingertips. So you should smart enough to perform the law of mechanics. It's very important. So let me take the process of structures. You know, the structures, it's a very big thing, very vast concept. So for example, for structures you can consider a building, Then the structures, actually it's a combination of structural subsystems. So if your structure is buildings, what we define as structural subsystems, we can say a foundation. Foundation is one of the subsystems. Foundation. Then we can say the floors, number of floors. Then we can say roof, like that, etc. Right? So foundation, floors, roof, these are called as structural subsystems. You know, the combination of structural subsystems only it will give your structures, the perfect structures. Then what you can do, these structural subsystems you can divide as a structural elements. So for example, if you take this floor, this is combination of structural elements. That means beams, it's combination of beams and slab. You know, these two, this small element we define as structural elements. You know, as a structural engineers, so when you think about the buildings, the whole structures, it's very difficult to deal with. Then what we have to do, we have to break down in the small pieces as a number of structural elements. Then finally we design each structural elements, so we can combine together, we can do the integrated design for the structural subsystems. Then from the structural subsystems we can move on the structures. So this is the process what we follow as a structural engineers when you are doing the design. So let me start with the structural element, the basic structural elements available in the civil engineering industry. So very basic one is the tie rods. You know, these tie rods, it's basically the element subjected to the tensile force. You know what is the meaning of tensile force? So for example, this is the picture of tie rods. You know, it's very rare in civil engineering applications, but in mechanical engineers, most of the vehicles inside the engine parts, and sometimes this is the tie rod is connecting two parts in the mechanical structures. The tie rods basically subjected to tension force. So what we define as a tensions, so for example, if you take this figure, so the force applying here, this member is subjected to some certain elongation, that means increase in its length. When you are applying the force in away from each other, so you will get some certain elongation in this particular member. So therefore this force we are calling as tension. Then what we define as a tension force, if any force when it is make elongation in particular member, so that force we define as tension. So if we talk about other directions, that means if it is a tie rods, it's not suitable in tie rods. Some case, so your force will be acting other directions. In this case, your member is instead of shortening, that means elongation, that means extending. So your member undergo the shortening. Your length is reduced. You will get shorter members. So in this case, this force we define as compression. Again I am repeating, any force, because of that force, if your member subjected to a tension force, what we define as a tension force, if your members, because of that force, if you encounter, then your member undergo any increase in its length, that force we call as retention. If a member undergoes any shortening or reduce in its length, that force we called as a compression. So let me take another structural members, so which is called beam. So you know, beams is generally the horizontal members. in your structures. In these figures there is a timber beam is shown. This member we are calling as a beam. Normally basically slab. So whatever the slab, it's connecting over this beam. It's supported by the beams, normally the slabs. So beam is the horizontal member. This beam you can classify based on it's according to the way it's supported. We can classify as follows. Here you can see this is we are calling as a simple support. What we define as a simple support, oh, so we'll talk about later some detail in what the types of support. So under that chapter I will explain more deeply. For the moment, keep it in mind. So if you support in these notations, that means these symbols, it represent your support is pin. So I will explain what is pin support in next chapter. So for the moment, keep it in mind. If a structure's symbols is like this, that is we call as a pin. So if your structure it's represent this kind of connections, this is called roller. So what we define as a simply supported beam, if your beam has only two connections, one is a pin, another one is a roller. So these two support, that means support we called as simply support. So that is what we are calling as simply supported beam. So we'll move on to the next one, cantilevered beam. So if you check these notations, it is different from these two what we discussed earlier. This support we called as fixed. This is fixed support. So I'll explain what is fixed support in next chapter. So for the moment, just take the basic idea. If beams, any beams, this end, another end of the beam, there is no any support. This is the free end. So one end is connected to the fixed support. In this kind of beam, we define as cantilevered beam. It's like a branch of tree. That is what this name came. Actually, the cantilevered beam. So here, fixed supported beams. So similarly, simply supported. Simply supported means in both end, pin and roller, your support is simple. If it is a fixed support, okay, from the name itself you can understand, you can able to understand. So in both sides you have fixed support. So the final one is the continuous beam. That means your beam has more than two supports. If your beam has more than two supports, it can be any kind of support, pin, fixed, whatever the supports. If it is a beam has more than two supports, that we define as continuous beam. In these three cases, your beam has only two supports. So here two supports, here two supports, here only one. So if your beam has more than two supports, that beam defined as continuous beam. So let me move on to another structural element, which is called columns. Generally the vertical member of the structures, this is in the structures. So these are the columns. Column is sometimes very high from the bottom. The end of the column will be the foundation, right? Basically the foundation is the end of the columns in most of the structures. Sometimes there are floating columns, it's a separate case. In generally the end of the foundation, that means column is a foundation. So what we define as a columns, it's a vertical members. Normally it carrying axial load. That means, so whatever the load you are applying in these particular buildings, there may be flow in the floors, there are certain loads. Load in the sense, it's loads coming from the users, sometimes the furnitures, sometimes the big soba, whatever the load you are applying in the structures, finally all the loads, it's reaching your earth, it's going to the soil, your ground. So what the in which way it's reaching the ground, the path is the column. Therefore column is very important in the structure and buildings. particularly if it is the column should be very strong enough to carry the load, whatever the loads coming from its supported part. So it's very important. So we'll look in details when you are discussing the structural analysis of columns. For the moment, you keep it in mind, column can carry the axial load. So sometimes movement as well, this is a separate case. This case I will discuss in the when the situation comes to our lectures. Definitely I will discuss in more details. So you know here the load is acting in these directions. I already explained. If the load is acting this direction, your member is undergoes the shortening. It's try to reduce the original length of the member. Therefore, this force we define as compression. Right? Okay. So let me move on to another structural element, which is defined as a slab. Slab is like a plate. It's like a plate. It's basically it's also horizontal. You know, this is normally acting as a floor of your building, right? You know, there are two types. The slab is a two types. You know, slab can be constructed anytime, any materials. The most commonly is a concrete and stone. Concrete is the most common one. We are constructing the slab using the concrete. You know, in slabs we can define as two categories. So one is two-way slabs, another one is one-way slab. What we define as a one-way and two-way. So you know there are two lengths. This is we are calling as span. So this one we are calling as long span. This is short span. You know, this longest span over shortest span ratio, if it is greater than equal to 2, that slab we define as a one-way slab. If it is a longest span over shortest span ratio less than 2, that is two-way slab. You know, equal sign is here. If it is equal also, that is one-way slab. So there are some exceptional case. In that case, your slab act always one way. So I will tell that part in later next chapter. So for the moment, this is the basic concept. You understand. You try to memorize this one. You should memorize this ratio. Long span over short span ratio. If it is greater than equal to 2 one way, less than 2, it is two way. So let me come to the another one. Another basic structural element is a wall. You know, wall like a columns. Column, you know, it's a certain. It has certain width and breadth, but height is very high. But columns, that means wall, it's not like that. Its thickness, it has a certain thickness, very small thickness. It has very large width. Width is very large. It's a continuous, it's a continuous column. So this is also vertical member. Normally we are constructing brick, concrete, stones. These are the material we are using to construct this wall. You know, dependent the nature of its uses. Some wall we are calling as load bearing wall. Some wall we are considering as non-load bearing wall. For example, in generally the brick walls, if the brick walls, the purpose of the brick wall is just like a partitioning. That means dividing the rooms, the partitioning your rooms and halls, your areas. So in that case, the brick wall, in most cases, right, brick wall we are considering as non-load bearing walls. You know, this is the load bearing, non-load bearing. It is this is not actual situation. This is our concept. But in actually all the wall carrying the loads. But in a structural concept, so we categorize as two types: load bearing, non-load bearing. So you will get some more details when we discuss the structural design, when you are discussing the designing of walls. Okay, so up to now whatever the element we have discussed, that is the basic structural elements. So now we are going to move some complex, that means combined structural elements, that means combination of these basic elements. So we will get another element. This is also we define as a structural element. The very first one is a truss. What we define as a truss, it is made up of by series of interconnected axially loaded members, you know. So if we take this one, this is we are calling as a truss. But why we define as a truss, the important part is normally the load, it's coming from the truss, from this joint only. There is no any other way. That means there is no any connection. You can see this is the usable part of the structures. So you know, from the usable part to the truss, so there is no any connection here. So you can see it's connected here. That means load is transferred to the truss through these connections. So finally what we can observe here, your members, it will carry only the actual, that means axial load, even it is tension or compression. You know what is the meaning of axial load? That means member, the load, it is coming, that means acting along the axis of member. So here in this case you will get tension or compression always. You don't get any other forces. There are other type of forces. I will explain when it comes to the forces. So this is we called as a truss, right? So it is consists of more slender members. It is very useful, you know, if it is your large span, your roof is very large, without columns you can construct uh, any length of span by using these truss members. It's very useful in particularly in very large buildings like factories, schools. So it's if you need very large spans, the truss is very suitable choice in this that case. So let me take another one, cables and arches. You know, in modern civil engineering arena, the cable and arches are very useful. So you know, it's particularly the cables are used in the bridge. You know, in this bridge, you know, the you know, you can see there are some lines here. So these are the, what is that, cables. You know what is doing here, you can see. So you, because of these cables, so you can have very long span without having the any support in between. So you can see very large span, you don't have any column in between. So why how can we maintain this very big large span? So because of these cables, you know, whatever the loads it's applied on this ground, it's taken by the cables. So you know, usually cables carry the tension force. Through the tension force, these cables, the loads finally reaches here, this pier. The finally from this pier, it will reach the ground. So this is we define as a load path. So this structure, this type of element we are calling as cables. You can see this bridge here. This is you know, kind of that mean curvilinear structures, curved structures. This type of structures we define as arch. You know, here the very important thing is this one also, you know, without having any columns in between, we can maintain some large span. So not like cables, we can it's moderately large, we can say. Whatever the load applying on this bridge, the finally it will reach here through this arch action, through this arch action. So it will transfer to these columns. Finally it is reaching the earth. So this type of structures we are calling as arch. So this is one of the best example for arch, the usage of arches in the civil engineering arena. Okay, so let me move into another one, another structural element called frames. Frames, it's very common in the particularly in high-rise building. You know, this is one of the example for frames. Frame can be made of with any materials. What is that? Concrete, steel, even timber. So frame can be made up with any material. You know, its frame is basically is a combination of column and beam. So this is the basic type of frame. This is called portal frame. That means two column and one beam. This is called as a portal frame. So as I said earlier, there are connection type. You know, it's here pin, rigid. We will discuss what is rigid connection, pin connection later. So this is we are calling as a frame. Frame. So whatever the load applying on this floor, so first it's transferred to the beam. Then from the beam it is transferred to the column. So finally it is that means accumulating, the column is accumulating all the loads in each floors. The finally very large loads you are getting at the ground floor level of the column. So that is what you can see. Normally the column size, when you are coming from top to bottoms, the column size sometimes at the ground floor level you will have very large in size. The reason is you are getting more load when you are coming from top to bottoms. Here you can see only this top floor load only transferring these columns. When it comes to here with this that means top floor load, there's another load coming from this that means consecutive floors. So finally you will reach very large load here. So that is what this is the load finally transferred to the earth. So this is the usage of your frame structures, frame element. When in the building, in the high-rise buildings, this is the frame actions. Finally, how the load is reached the your ground. Okay, the final structural element what we are going to discuss here, that is space structures. You know, the space structures, what we define as a space structure. Space structures is not like columns, beams, it's not like a members. It's a continuous structures. Normally it is very small in thickness compared to other dimensions. You know, you can see here this part, this is we are calling as a dome. This is kind of a safer structure. You know, this dome is it has the certain thickness, but in this thickness you can construct a whole members. The whole thing it acts as a one element. So this is it will create some that mean surface forces. That means forces can be created in both direction, in all the direction within this element. If you take this element, one small element here, right, the force can be transferred in all the developed in all the direction of this element. So through this the dome actions, the finally the load is reaching your columns, then it will transfer to the earth. So this type of structures we define as dome structures. Okay, that's all in this my first lecture. In our next lectures, I'm going to discuss the load. Then from the load, I'm going to move on analysis. I will explain step by steps how to calculate the internal forces and how to design the members. I will discuss the design based on the British standard. Sometimes I will, if I have a time, so I will discuss the American standard as well. Thanks a lot for watching. Subscribe for more videos and give your feedbacks for your future updates. Thanks a lot, guys.